Hello, I'm Jay Liu and welcome to this video. Because of the advantages of large amount of satellite images and climate data, machine learning, which is a virtual subset of artificial intelligence, can be applied to Earth observation to categorize and modify large volumes of data. We will work with CS and lead classification in this video, and we also will use Python coding by Google Colab. To begin, open the Jupyter notebook that is accessible through a link on the module page. Next, go through this introduction to AI machine learning and select Google Drive. Then you can download the Week2 folder here. Click here to view the first interactive code on Google Colab. To connect your systems, click the Connect button here. After that, you will need to provide the rights, import the packages, and update the path to your own Google Drive. This can be achieved by going to Week2 on the left, clicking the three dots next to the CS and the lead classification file, and copying the path to path here. Make sure it's running, and change the mask area to the mask to match yours. So in this example, we do 100, 700, 300, and 1000 as simple one. The next code segment verifies that it plots images and extracts the suitable section or region of interest. So in some of the subsequent cells, 3x3 patches are created to assist in training each pixel by utilizing the surrounding pixels. Remember that we have 21 bands, thus we must repeat the pressure throughout the whole image, because not every pixel will be completely encircled by 8 pixels at the edges and corners. The next three cells balance the amount of leads and CS in our data. So at last, saving the files as training and test files is the final step. So we can go to our own Google Drive and go to Week2, so we can find the files here. So we can go to our own Google Drive and open the second Google Colab file here. This chapter helps us with surface discrimination. We utilize 21 bands of images, which yields 59,000 pixels. We select some data for testing and others for training at random. So press the Connect button here and mount your drive. Install the necessary packages, then modify the path to the location where you saved the X and Y train and test files in the last section. You can specify the paths to each of your X and Y train and test files by clicking on the three dots on the left that appear next to them. So we can paste the path here. The CNN section comes next. CNNs use a number of layers to learn spatial hierarchies. These layers first identify edges, then combine those edges to identify shapes. Additional layers may then identify more complex structures. You can apply this model to upcoming input features by going back to the shape that is consistent with the data you want. Random forests are important AI tools for classification tasks. They use a subset of different areas of the data to make predictions. Here is the code using the function CLF, and we use it to define X-train reshift. The next is Vision Transformer. It is a neural AI tool that specializes in image classification. It is highly effective at training and can be scaled up because it follows a series of phases. The cross-validation and model selection, which are important techniques for avoiding overfitting. We want to get something like the curve in the middle, which shows an underfitted curve on the left and an overfitted curve on the right. The manner we select to classify lead and S can affect overfitting and underfitting. For instance, if the top left is 0, then all S should be classed as S, and if the bottom right is 0, then all lead must be lead. Cross-validation assesses a model's performances by repeatedly dividing the data set into training and validation states. The most popular technique for this is k-fold cross-validation, which divides the data into k, which is number of equal-sized subsets at random, and selects one as the validation subset. Here is the code for that part. Make sure to look at the numbers below, because they are important for quantifying the results. So this video will enable you to begin developing a basic model for classifying lead and CES. I appreciate you watching. Thank you.